Hello, everyone. And this is the first special crypto talk series live from Neuchâtel. Well, partially, I'm in Neuchâtel, and there's some other people from Neuchâtel too. But we were supposed to have Cheng with us in Neuchâtel. Sadly, because of some specific Neuchâtel rules, we had to cancel the physical meeting. And then when we cancel it, people were actually saying, no, we want to still listen Cheng. We want to hear Cheng about Alephium. And so people requested that we were going to do this online, and so we did. So thank you, Chan, for being here still with us, and we still have a couple of seconds before we can start. Thank you for Polto also for organizing this. So yeah, let's start. Very quickly, I'm just 1 minute to introduce first the crypto talks of Neuchâtel. Welcome everyone to be here. I'll do it in English because the presentation is in English. So normally we have a small almost every Thursday now in Neuchâtel in the co-working, and everyone is welcome to speak. There you have the list is available in the Blockchain Neuchâtel channel on Telegram. We also share it on the DeFi channel that Cyril is maintaining. If you want to do a talk in Neuchâtel, please send me a private message on Telegram or just write on Blockchain Neuchâtel and say, hey, I would like to talk. And we really kindly, we are really happy to have you there. The idea is that you can present, right now it's pretty free. If you want to present your commercial project, you can. If you want to present something else, you can, about crypto. And we're pretty open, and I think it's where challenge, and this is what we appreciate here in Neuchâtel, that when we have a small talk, then there is the beer-to-beer, and we can challenge, people are challenged in their thinking. That's the cool part in Neuchâtel. So yeah, if you want, the next event is going to be next year, so this is the last event, and yeah, please send me a message if you want to. Next, we're going to Cheng from Alephium. So welcome, Cheng. I'm really happy to have you here. I think we're going to go directly deep dive into Alephium. I have a lot of questions. I hope we can hear from two really interesting things from Alephium, which is the proof of less work, which is iteration of the proof of work, which is interesting, and then the other thing, DAG, the block flow, the sharding on top of UTXO blockchain, and really excited to hear more about this. I will have one question that I will ask Cheng immediately now, and then he can think through all the time, through all the presentation. Do you think ever that at one point you're going to backport those two main innovation of Alephium to Bitcoin? Are you going to try to do this? So, because I think it could be compatible. So yeah, welcome, Cheng, and you have the floor.
Thank you, Alexis, for the introduction. Can you hear me? I'm not sure if I set up correctly.
Yeah, we can hear you perfectly.
Okay, great. So I'm gonna do a little bit more technical introduction of Alephium. I guess most of you have been for quite some time, and you have already know the basics of Alephium. So I think it's good to dive a little bit more into the depths of Alephium. I'd first like to introduce myself a little bit. So in the past I did 2 PhD, both dropouts, one PhD in mathematics and another PhD in consensus algorithms research in EPFL here in Lausanne. That's why I stay in Lausanne for more than 8 years already. And so my PhD experience actually is very close related to blockchain. That's kind of led me eventually to work in the field. And during my PhD, I proposed the first linear time asynchronous consensus algorithm. And from 2018, I started to focus on my study to work full-time on Alephium project because I was not really happy about the other projects, the progress on sharding, especially the Eastern 2.0. I was following it since 2016, and they did not deliver at 2018, and still not fully delivered nowadays. So that's why I decided to work on it 2018. I'd first like to describe what kind of problems we try to solve in Alephium. There are many two parts. The first part is the scalability. This we have already know. Mainly two parts. The first part is the execution part. Is right now, like Bitcoin, Ethereum, they are a single blockchain. So it means you have to execute the blocks one by one. This is the sequential execution. On the other hand, like nowadays, all the computers, you have multi-cores, multiple processes. So you could actually execute a lot of things in parallel. So that's the same for blockchain. You can, if you have the algorithm, you can actually execute the blockchain in the blocks in parallel. This could improve the performance a lot, and also the throughput. Another part of scalability is mostly from the user side, is the like transaction fee, and also like the full node is too heavy, the state is like exploding along with the time. That's the mainly the challenge of scalability, the two parts. And then another problem I want to highlight is the security of DeFi. If you have been follow up the development of Ethereum, especially the DeFi, you probably see that a lot of hacks happened in the past 2 years. Some of them like make users lose dollars. So here, part of the issues is because of the code is not written well, and the part of the issues actually is because of the virtual machine and also the programming language are not designed properly. For example, the front running, like the flash loan. Flash loan is a little bit controversial because it brings both good and bad to the system. So here we want to solve, at least to improve the DeFi security issues, not to solve it completely because that's not possible. So Alephium, we try to target these two main challenges: scalability and the DeFi issues, security issues. The approach we took actually is very much following the Bitcoin philosophy. We try to find the very simple and the very robust solutions that can be sustainable for the long term. It's not like we try to, for example, there are some projects they try to solve these problems by just fork EVM and improve the transaction throughput. That's actually, it can work for the short term, but it will not work for the long term. What we are doing in Alephium is we try to find simple and robust solutions that could work for like next 10 years, 20 years without a problem, like Bitcoin have done right now. And then we can improve the tech stack along, in the following years to keep making more efficient to be sustainable for the very, very long term. So now I'm going to dive into how we solve these two problems. First, the scalability. As I mentioned, that scalability, there are many dimensions of scalability. So scalability, we have different dimensions like transaction fee, throughput, and the latency of transactions, and also like how is the hardware required for running the full nodes. Like there are so many metrics. Ideally, we want to make a blockchain that can have like nice metrics on all of these dimensions. But in reality, it's not possible. We have to make trade-offs dimensions. For example, like Bitcoin focus on the lightweight of the full nodes, so that everyone can run it on a very lightweight or very low-end computer. And the block time is 10 minutes on purpose, so that it can be sustainable for the long term. But this means that latency is higher for 10 minutes. The good side is like it's really lightweight. It's probably one of the most lightweight blockchain on the world. And on the other hand, Ethereum is a bit nowadays is a bit too heavy to run it, especially if you try to run the archive modes. It's going to use like I think it's like at least 10 terabytes of data. And there are a lot of new blockchains like Polkadot, near Solana, or for some trust models for better performance. And here comes the question: what do we need for the decentralized finance for the future? We want to have a high performance blockchain that is very hard to maintain, like Solana or like Polkadot or Near. Or on the other hand, we would like to have a scalable and decentralized blockchain that could we could run it on Raspberry Pi, we could run it on a laptop. Still, we can get the scalability and we can get the DeFi stuff. For me personally, I would like to have the second option because that can be more decentralized and can be more sustainable for the very long term. And I believe that right now on the markets or in the crypto space, we have too many blockchains that are following the first approach. They provide very high performance, very high TPS, but very few teams can actually maintain the blockchain. So I believe that Alephium is very unique in terms of this. So now I'd like to like speak about how we achieve this, to achieve scalability, achieve sharding, while still keep the blockchain to be lightweight. The algorithm we invented is called the block flow. We are a sharded blockchain. We first need to do some sharding of the state of the blockchain. The sharding is based on the addresses. First, we randomly divided the addresses into G groups, and then the transactions they are divided into G square groups based on the input and the output of the address. So in this case, we have G times G blockchains in total. And then we have so many different blockchains. We need to reach consensus for all of these blockchains. That is not trivial. It's much more difficult than if you want to reach consensus with just one blockchain. So here we invented the core algorithm. It's called block flow. Basically, is a specialized DAG-based algorithm. And with this algorithm, you're going to choose a based block for each one of the server blockchain. And eventually, you're going to reach consensus for all of the blockchains. I don't want to dive into the details, but if you are interested, we have more details in the technical white paper. And with this block flow algorithm, we can basically achieve something very similar to Bitcoin. You can reach consensus with the proof of work. The very important in our design, the most important part is Alephium is based on UTXO model. Why UTXO model is very critical for our algorithm is because UTXO model is much more immutable. In the output of the transactions, you cannot modify the state. And the next time, if you want to do transaction, you need to spend these UTXOs. So this immutability is much better for scalability, and is also the best candidate for a sharded blockchain. So we use UTXO model for sharding. I don't think there are any other blockchain following this approach, as far as I know. And the second one to highlight is we use proof of work for sharding, and this is also very unique. right now, all of the sharded blockchain like ETH 2.0 or like a near blockchain, they are based on proof of staking. Basically, the idea is like they have a main chain which we all use to store all of the validators, all of the information. And this is actually non-trivial, and it took many years for Ethereum 2.0 to really build up the big chain. And we are based on proof of work. This is much more lightweight. We don't need to maintain the miners. We don't need to have the information from the miners. And the miners will distribute the hash rate for different blockchains to mine on them. And we, with our block flow algorithm, we can still guarantee that if one want to attack the blockchain, you need to have 51% of the hash rate. So that is perfect. It means we did not sacrifice the security, and on the other hand, we build something that is much more lightweight than Ethereum 2.0. The third feature I want to highlight is we are actually the first sharded blockchain to support single-step cross-shard transactions. This means if your address is in one group and you want to make a transaction to another group, you just need to do one transaction, just like how you do transactions on Bitcoin. So this is actually not trivial, and is not available for in many of the, actually in almost all of the sharded blockchains, like Ethereum 2.0 or like Cardano. You need to have at least two steps. It's two-phase commit protocol. That is actually not user friendly. I believe that if you ever have tried like some of the other sharded blockchains, you're going to see this issue. It's not so easy to move funds across different chains. But in our case, it's actually really easy, really simple. You can do this cross-shard transaction with just our wallet or with our phone nodes. Has been launched for one month. We never have problems. We never see people have problems to move funds from one group to another group. This is actually one of the greatest feature of Alephium. And the last point I want to highlight is, as I mentioned, that we prefer or we favor like a very simple and a robust approach. We based on proof of work, based on UTXO model. And this has been battle tested for many years by Bitcoin. We follow the same approach. So the last point I want to mention is the comparison of the performance. So because we follow Bitcoin approach, we will not achieve the 1 million transaction throughput blockchains. I don't know if it's true. If like the other project, they claim that they can reach 1 million like transaction throughput. But in our case, if we make the G to be 32, we can reach 10K TPS, and that is the kind of the upper bound nowadays for the decentralized blockchain, and based on the current network bandwidth. And right now we have 4 groups, and that is way too enough for now, because we don't have any real transactions. Don't have too many real transactions. And once we have bottleneck for the throughput, we're going to increase the number of groups, and the throughput can be increased a lot. So that's basically the overall the comparison of our approach with the other approaches based on proof of staking and and other projects. As we can see that, I want to make a conclusion is like we are really scale the blockchain following the same philosophy like Bitcoin, so it can be more sustainable for the long term. We all agree that Bitcoin has no problem to survive for the next 20 years, I would say. I mean, technically, and the Ethereum actually is right now is having technical problems, scalability issues right now. If Ethereum they cannot innovate, they are going to probably have big trouble. That's why we decided to follow the same approach as Bitcoin, and we managed to do that. So as you can see, like the mainnet is live. We have achieved all of the things we wanted, and because we are using proof of work for sharding. There's a naturally there's a question people will ask is about the energy consumption. Right now, I'm not actually. Bitcoin right now consumes around like 0.3 or 0.4 of the global electricity. A lot of people question that this is actually too much. Personally, for me, I think maybe 0.2 can still be secure enough for Bitcoin. We don't need to go up like 0.4. So if we think this is kind of a good argument, then we would say that we reduce the energy consumption a little bit while still make the keep the network as secure. So in this direction, in the research of this direction, we come up a new algorithm. It's called the proof of less work, reduce the energy consumption of proof of work. So the main idea is to move some of the cost in the physical world to the internal network cost. For example, like right now, if for mining you need to mine like you need to spend 1 Bitcoin to mine 1 block on Alephium. If we move like let's say half of the cost into the network, you need to burn half of the half Bitcoin on inside Alephium the network, and you need to spend another half of Bitcoin in the physical world to do real mining work. And then in this case, the energy consumption actually is reduced by half, but the security is still the same because the cost for the miner is still 1 BTC. That is the basically the idea behind the proof of less work. In how to design it properly, and you have to burn the cost or burn the coin inside the network. I'm not going to dive into details, but we have a technical paper in our GitHub or in our website. You can read it, and we can discuss on Discord. So far we have talked about scalability and how we reduce the energy consumption of proof of work, and then we are going to come to the last topic about DeFi, about the smart contract. As I have mentioned that we follow very closely the design of Bitcoin using proof of work and the UTXO model. But there's one thing that people really want is to have on-chain smart contract or on-chain DeFi on Bitcoin, right? So we also added like make our model or make our design to fit with this really important feature is smart contract. As you probably some of you have know that there are some other blockchains have already been using UTXO model for smart contract like Cardano, like Ergo. They use a model is called the extended UTXO model. So basically the idea is to put some of the smart contract into the output of the UTXO, and then next time you spend the output, you could actually call the smart contract and do some more complicated logic based on that. There are some issues in this approach, especially the concurrency issue. Like I think in September this year, when Cardano launched their first DEX platform, like people have issues to of transactions. That was the issue of this model. They are working on that to improve it. And on the other hand, in Alephium, we try to follow another approach. we create a new model. It's called the stateful UTXO model. And this model, I would say, is a combination of the UTXO model with the Ethereum's the ETH's account model. So we add the states to the UTXO model instead of put the states into the output of the UTXO model. In this way, it means like UTXO part of UTXO is still very similar to Bitcoin. If you don't use the smart contract, so our tech stack is really just like a sharded Bitcoin, just like a sharded Bitcoin. But if you want to use the smart contract, then it's like the user experience is very much like Ethereum. That would be great. The state is immutable. Sorry, and the state is mutable. Because of this, users will not have the same issues as like what we have seen in other extended UTXO model blockchains. There are a lot of interesting features I want to talk about stateful UTXO model. First, the token are first-class citizen. This is very useful because right now on Ethereum you have a lot of different token protocols like ERC20 and a lot of ERC. The problem of this approach is that you don't have the built-in support. It's not user-friendly. First, it's not DEFI-friendly. You need to wrap a lot of coins for a lot of smart contracts. And the second part is the security. Actually, in the past, we have seen some DeFi hackers. That's it because due to the design of these ERC token protocols. So it's not so easy to design a protocol that will be used by multiple million or even like 1 billion business. That's why I think like built-in token support is very important. The third thing I want to highlight is because we are based on UTXO model, we can actually support multiple participants in just one transaction. For example, if Alex want to transact some exchange some token with Barbara, he can just two of them can just sit down and prepare the transaction with one input from Alex and another input from Bob, and then they can do the transaction, can do the exchange in just one transaction. And this is very much more user friendly than Ethereum. On Ethereum, you are going to need to at least I think 3 steps. Start. And the third feature I want to highlight is our model is very we focus on very much on the security, especially we disabled a lot of the flash ROM based attacks. We enable this by make each of the transactions the atomicity of the transactions to be more fine-grained. So it means in each transactions you have to focus on what you want to do in just one round. You cannot put multiple steps into just one transaction. You're going to compose through multiple transactions instead of compose them inside one transaction. Why I think this is a good design? Because on Ethereum, if you want to do some arbitrage, you can do a lot of things in one transaction, and then if you see that there's no profits, and then I just quit the transaction. So this we usually call this risk-free arbitrage, and it's not good for the ecosystem because basically the hackers or the arbitrators, they are kind of like taking money out of the DeFi projects for free. Yeah. So that's why we designed this new model to improve this problem. I think I'm not sure if we are the first one, but we are definitely going to be the first one with this inside the virtual machine. So that's those are the 3 main features I want to highlight for our DeFi design philosophy. And internally on the project, we have two parts to implement these goals. The first part is the virtual machine. We call it 5VM. Is a domain-specific virtual machine that's focused on decentralized finance. Actually, focused on token. And in the virtual machine, you have a lot of like safety checks, like safe mask, safe access control, and the safe types. And all of these are missing from EVM, especially the safe access control, which is like I think is a huge concern for the whole DeFi ecosystem. Right now, if you want to use a lot of the DeFi applications on Ethereum, actually you have to provide unlimited access control to the basically to the DApps. It means like you open your pocket completely for the other for the DApps. You have to trust that there's no bug in the DApps. If there are some bugs, like the hackers might take all your token or take all your coins away. So we fix this problem in the virtual machine level. It's going to be much more safer than the whole EVM ecosystem. And another great thing about our virtual machine is it's much more lightweight. It's similar to JVM. If you know a little bit about EVM, actually EVM is not efficient. It's not so. I would say if you compare to the programming language, actually is like the Fortune, probably the Fortune virtual machine, very old ones. So we follow the similar approach like JVM. Is going to be much more efficient. Also, it's much more readable. It's much more friendly for developers. And the second thing I want to, the second great thing about our VM approach is that it's much more safe, and also is more performant, like JVM compared to the older versions of or older generations of virtual machine. The third part is about the I/O optimizations. Right now, actually, one of the main bottleneck of EVM is the I/O parts, because the whole state of the Merkle tree is actually pretty huge. If you for any of the DApps to operate on the Merkle tree to read or write data is very expensive, and also is not so efficient. So we design something different. We remove the contract tree away, and we make sure that each contract can have a limited state. In this way, we make a trade-off. The I/O is much more efficient than EVM. But the drawback is like we are not going to support a lot of this, not a lot of some of these features on EVM. But right now we can do a lot of the popular DApps without any issue, and the gain is actually a lot. The fourth point I want to mention is about the security against the arbitrage, especially the front-running stuff. Right now on EVM, you probably see like a lot of articles about minor extractable values, or like front-running bots, etc. This was like a very competitive field right now on Ethereum. And we don't think that is a good way, because it creates a lot of useful transactions to the network, and also increase the network load in many cases. I don't think arbitrage is a bad thing. Arbitrage will always be on a lot of blockchains, but the main problem for Ethereum is like the almost risk-free arbitrage. A lot of front-running bots, when they see some potential arbitrage opportunity, they will just send a lot of transactions to the network, and this is not good for the robustness of the network. So we try to fix this problem. We introduce something called a random execution of transactions to the virtual machine. You have a block, and you have a list of smart contract transactions, and the virtual machine will execute them not from the first one to the last one. They will execute them in a random order. So in this way, if you, for example, if you want to do arbitrage, you send one transaction, but actually you are not guaranteed to do to make sure that your transaction actually happens before the arbitrage opportunity. So this actually is very important to make the arbitrage to be risky, and in this way, the network is much more healthy because the traders they need to pay something in order to gain to get the arbitrage opportunity, and this is going to be more healthy for long term. We also eliminate many of the EVM attacks, like the re-entrancy attack and also authorization, the double dip issues. If you are following about EVM, you're going to see a lot of these hackers in the past, and all of these are avoided just because of the design of our virtual machine. This is super good because right now on EVM, or if you want to develop some like DApps, you need to pay a lot of money for just to get your project audited. Usually it's like a $50K dollars cost if you want to get your project to be audited properly. But on our case, because we eliminated many of these attacks, it's going to be much more like friendly for developers, because when you develop something, you are sure that you don't need to check a lot of these attack vectors, and you just need to focus on the logic of your application. So that is great. So we have like so many great features on the virtual machine side. Natural like the question people would ask if it is things is such a new thing, and also things is it has so many great features. Does it mean like it's very difficult for developers to learn from it? So my answer is actually we design a very user-friendly and also a very developer-friendly language. It's called the Phyla. To help people to code on Alephium. It's a language that is similar to Rust. And the people have some knowledge about, I think, JavaScript or Rust. It's very easy to learn about this. It's designed to be a very simple language. And on the other hand, we hide a lot of the internal details away from the users. I think that based on our experience, because right now in our team we have 2 people are working on some a voting demo. Based on my experience, is like once the developers know some basics about the UTXO model, about some of the kind of the constraints we have in the UTXO model, it's actually pretty easy to develop the apps. And also we have a lot of like smart contracts already in our source code, many in the unit test or in the integration test. So we have a lot of samples. Right now, the main problem is the documentation. We're going to improve them very soon. So that's basically the overall introduction of our smart contract design, the virtual machine, and the language. And the next step for the smart contract is we're going to build more and more demo applications, and we're going to improve the documentation, and also we're going to build some decks, bridges, and oracles to basically to make the infrastructure for DeFi. And then we're going to onboard more and more community developers. to build like the apps on top of it. Okay, so I think I have done my presentation for the whole project from a technical point of view. I'm not sure if I describe it well. I'm not usually a good person to describe things. I'm more like used to build things and write code. So last, I want to summarize a little bit about the whole project. So Alephium has been launched for like 1 month, actually a little bit more than 1 month. Like before the main launch, I believe that a lot of people never heard about ours, and we were mostly focused on development since 2018. Yeah, and since like 1 month ago, since we launched the mainnet, we get a lot of people to join the community. And since the mainnet launch, we improved a lot, like the full node, the robustness of the full nodes, the usability of the wallets. We improved the performance of the miners, and also we released the first version of mining pool. And the network is growing very well, especially for you probably see that the hash rate has increased by at least 10 times. The community is also growing, and we see like more and more people are helping in community development, and this is great. I believe that for the first month, the team and also the community has done a great job, and we are really excited for the future development. And for the next step, I think first we're going to improve the community development. There are still a lot of things we need to do, and for the first month we did not have enough bandwidth to focus on that. And I think from the second month we're going to improve a lot on that. And then we're going to actually, we have been already started is about like exchange listing. We are going to talk to we're going to probably implement hardware wallets, and also we are going to talk to other like mining pools to integrate our mining infrastructure to the to different mining pools. And last part is about DeFi, as I have mentioned. That's a huge field we're going to focus on. We're going to improve a lot. Yeah, so a lot of exciting things is going to happen. We are really looking forward to it. I guess that's it. I'm going to take a lot of questions from you if you have any. Thank you for listening.
Yeah, thank you very much, Chang. So I have people in the question.
Alex, it seems I cannot hear you like very well. I don't know why.
Very well. You cannot.
It's like yeah, it's a little bit like I can hear like 50% of your voice.
Oh,
Yeah, it's cutting a bit.
it's like it's cutting. I'm sorry. My connection is. Sorry. Hopefully, so. Polto, you want to lead the questions, maybe with the people?
Yeah, so first maybe Alexis asked the question at the very beginning. Do you think it's possible to bring these innovations back to Bitcoin? Like the sharding, the proof of less work, and maybe the stateful UTXO model?
So first, I think theoretically this is possible, but in practice it's very, very hard. You know, like even adding no signature to Bitcoin takes ages, right? So I think like it's really hard to push this for Bitcoin. I remember like probably 2 years ago when we made with Peter Weir, right, in Germany. Germany, we asked him like it's possible to implement proof of less work for Bitcoin. He was saying that it's very hard to make a hard fork for Bitcoin these days. So it's kind of like impossible. I'm not sure if this is
Definitely.
the right answer.
Yeah, and as I understand, most of these changes can't be implemented through a soft fork. They would require a hard fork.
Yeah. And another thing I want to highlight is actually the source code of Bitcoin is very hard to maintain nowadays because of the tech dates. So if you want to make a big change to Bitcoin, it's going to take ages as well because you need to get a lot of reviews, a lot of approves from the community. It's very hard as well.
So if people are willing to ask any question, please jump in. You can press the button on the left of the microphone and ask your question.
Looks like people understand Alephium. So
Don't be shy, and if you don't want to talk, please just write it down. Oh, I see Weedcoder.
Hello, can you hear me?
yeah.
So the question is, how does Alephium's VM compare to main competitors such as Cardano or Ethereum?
I think we improve a lot of things over EVM, so it's definitely going to be a good candidate for many new applications if you have high security requirements. But right now the main issue is the whole the tool chain around it. Right now we are still a very young project, and we don't have a lot of tools for, like, for example, the compilers is not that user friendly, dev friendly. We don't have IDE to program these contracts, so that will take a little bit more time. Otherwise, I definitely think that is going to be the candidates for building like the apps. That's the first part, and the second part is the ecosystem. If you want to build the app, you need to have like good liquidity, right? You need to have a lot of people to use it, and right now most people are using EVM projects, so it will take some time for us to bootstrap. But I believe that's because of our technical advantage. We're going to attract people eventually, like how we attracted miners right now.
Okay, thank you.
Thank you.
Okay, if
Go ahead,
yes.
I see Tobias' request, but I'm not sure how to authorize him to speak. Normally you can.
Tobias, you
Sorry?
need to. Tobias needs to accept. You have the.
Tobias, I think it's on you. You should click somewhere. For me, it's saying invite sent.
Hey, change. Let me here. Okay, back. So stateful Joel, then you are allowed to.
Okay, I'm not sure if I need to do something. It's a allow request from everyone. Seth, maybe you can help us.
I mean, I also just had a look. I also just had a look, but
Okay,
it seems
maybe.
like we sent the invite, and the two people that want to speak, they need to accept it. But I'm an admin, so I don't see the same thing as everyone. Oh, Tobias is here, so I will stop talking.
Yes, I'm spamming the button. I had some troubles clicking on it. Thank you very much. I had a question on the positioning of Alephium because it's really hard to keep the visibility on how it positions compared to others. So Cheng has really put a lot of thoughts into words. Do you think it would be possible to have some kind of visual representation on the positioning of Alephium compared to others with scale on centralization, on speed, and other things like creating some graphical view? Do you think that's something that would be feasible?
Yes, definitely. I think we have a lot of such materials in the past when we talk to investors or we do presentation, but we need to probably to just collect them and show them properly. So that's definitely. On the other hand, I think we can, because I give a long talk and maybe it's not so clear for a lot of people. In my opinion, Alephium's positioning is to be really a decentralized and scalable blockchain, and this is not today is not really. There's no other blockchain is doing this well, and so we believe we are in a very sweet position. And on the other hand, there are a lot of people try to improve scalability, but it's not great. That's the part we improved as well. Especially the mainnet is live. People can taste it. We can see that actually the user experience is very good. Like a lot of users don't even need to feel that it's a sharded blockchain. So I think we can summarize the whole thing in one sentence. It's like the decentralized and the sharded blockchain with the best user experience right now. I'm not sure if I answer your question.
Kind of. The question was more directed onto I think at this stage a lot of technical people understand why it's cool, but it's really hard to say to pass the virus over to others that are not as technical, and so even in our teams when we talk and we're trying to explain, it's hard to find simple words or simple graphical representation of explaining what makes it cool.
Yeah. Okay, we'll work on that. I think we have.
Yes, we'll work to make it better. I think, it all depends at which level you want to go, right? I mean, if you really want to go super high level, you can say it's a blockchain that brings scalability to the Bitcoin technology stack, and combines it with the programmability that you can find on Ethereum, while and because we are based on Bitcoin technology stack, we have a much higher level of security. Basically, it's the security of Bitcoin, the programmability of Ethereum improved with scalability. If you really want to keep it super duper high level, but we'll improve and try to create more content so that this is more easily digestible for less technical audience.
Awesome.
All right, we have Note 33, please.
It's Elias from the Alephium team. Can you hear me?
Yeah.
A really nice example that I think Polto gave me one when comparing Alephium to Ethereum or to Bitcoin was the example with the bikes and the locks. So if we imagine at least the security of the project, Bitcoin would be a bike that every time you want to live somewhere, you lock it with 300 locks. So yeah, it's definitely secure. You're sure nobody's going to bother stealing it, but you also need to unlock 300 locks every time you need to use it. Then Ethereum, or maybe not Ethereum, maybe it's not a good comparison, but a proof of stake blockchain would have one lock. So you still your bike is probably still there, but it's not as hard to break one chain compared to 300. And then what Alephium tries to say is that, okay, we don't need 300 chains, but we want more than one chain. So maybe 4 chains are enough. You can lock the front wheel, the back wheel, the body of the bike, and you can add another one. And it's relatively fast to unlock 4 chains, and it's much more secure than having only one chain. So I really like this comparison when I try to explain what do we do to non-technical people. I think it shows a good, very, very high level example of what we're trying to do to find the sweet spot between security, scalability, etc. So yeah, I wanted to add that. Thanks.
Thank you, Elias, and also thank you, Maud. So definitely, I'm not the best person to talk to if you want to get like a base high-level overview of the project. I believe I'm more like suitable for technical questions.
Can you hear me? Yes. I have a question about block flow. Could you maybe, in terms, decorticate and explain what happens and how it goes?
So we can probably explain it in like if we are in a like a very ideal network, and each one of the sub blockchain, they will produce block at the pace of 1 minute. It means like right now we have 16 blockchain, and every minute each one of the blockchain it will produce 1 block, and every new block you're going to include not only the parent the parent hash of your own blockchain, you are also going to include some of the hashes of the other blockchain. So this makes it a DAG-based approach. But this is not enough, because, for example, if you try to include all of the hashes of different blockchains, it's not going to be efficient, and also is not going to be so. The parallelism is not high enough. It means there will be a lot of like ultimately it will become a sequentialized blockchain, and like the traditional classical blockchain. So in this case, you need to be smart in how to find out the dependencies. You need to make sure that it's easy to calculate and is efficient to verify, and also is kind of easy to prove that actually is correct in the mathematical way. And we managed to find a good balance in this way, and also make sure that it fits very well with the structure of the blockchain. And our structure is very unique. We have G groups, and we have G times G number of blockchains, and this is a very unique structure of a very unique sharded structure. And this structure is very important to achieve this single-step cross-shard transactions to get the best user experience. So that's basically the most tricky part of block flow, is to find out how to calculate the different dependencies and how to make sure that is correct. And so actually this problem is very you have the similar problems on Ethereum 2.0, and people call it as the fork choice rule. You basically could consider our block flow algorithm as one specific of this kind of fork choice algorithms. Yeah, that's it. And with this, you just need to prove that all of the selections are compatible with each other, and then you need to prove that if you want to attack it, you need to attack all of the other blockchains. But this actually is pretty easy because you have dependencies from one blockchain to another blockchain, or to the other all of the other blockchains. If you dig a little bit deep, yeah. So that's basically the way. If you want to attack one blockchain, you need to attack the whole network, and then you get the same security like a single blockchain. I'm not sure if it's clear.
Yeah, I think it was clear. Thank you very much. We have other questions from. Otherwise, I have one. Will hear me correctly? Not to cut. What is the kind of like mining industry, or what is the to look like when Alephium is really widely? How do you feel it's going to be?
I did not hear like 100% of your sentence, but I guess you are asking about what kind of proof of work algorithm we are using, and how it will evolve in the future.
Sorry, no. I was saying more, how will the industry look like? The mining industry look like? Miners or like more individuals?
I think it will be very much like Bitcoin, because we try to follow the same approach as Bitcoin to be ASIC friendly. Right now, there are basically two approaches to go if you want to use proof of work. One of the way is like Ethereum is memory bounded. It means if you need to mine, it's better to go for GPU. And another example, another direction is like Bitcoin is very ASIC friendly, and ultimately, like everyone will have to use ASIC machine to mine it. So from the very beginning, we did actually extensive investigation over these two different approaches. And we believe that actually the ASIC friendly one is for the long term, because the algorithm is much more simple, and so it's very easy, and also it's fair for different companies to make ASIC miners. On the other hand, for Ethereum, actually is, I know that there are some teams they can optimize it a lot, and this kind of special optimization is not available for general miners, and this can be an issue for centralization. That's why we follow the similar approach like Bitcoin. So I think for the long term, the mining industry of Alephium will be very much like Bitcoin. It's going to be we're going to have mining pools, and the individual miners they will connect to mining pools to mine on the blockchain. And ASIC machine will be produced if the project grows well.
All right, Tobias, you can speak if you want.
But you need to unmute
Yes.
yourself.
Yes, indeed. Just a follow-up question on ASICs. What would be the the best guesstimate on when ASICs would replace FPGAs? Are we talking about 1 to 2 years or shorter, longer? What's your best guess on that?
So I don't have a good answer for that. Based on my experience in the past, is usually like 1 to 2 years. People will see the ASCIIs come out if the project goes well. In our case, I don't believe like ASCIIs will be available in the first year, but maybe like 1 year, after 1 year or 2 years, we're going to see some. And right now, I'm not sure how performance like ASCIIs could achieve. We are very similar to Bitcoin, but a little bit different. So which will make the optimizations not so trivial. So I'm not sure about how far we can go, how far the ASIC machines can go. But let's see. Is the market will tell us the answer.
Thanks a lot.
Thank you. Le Tour Powers Combine, I think you have the
Yes, thank you so much.
hour.
Yes, thank you so much for the presentation. I was wondering about some context for Alephium in terms of, well, wondering what is the context it's designed for when it comes to things like security and the assumptions with that. And the analogy I would make is that, as you get more and more localized, presumably distributed ledgers need less and less security because there's trust built into the context, you have local reputation, you have non-technical ways of mediating disputes just through kind of people talking amongst each other and monitoring these things. And as you get less and less localized or more globalized, presumably then there's less trust in the context, so then you need more security and you can't make the same assumptions. So along those lines, my question was, what is the context that Alephium is designed for?
I'm not sure, Porter, you want to talk about this? This sounds a little bit more like non-technical for me.
I mean, it's definitely the global scale where you don't know the people with whom you're interacting and where you need this trustless way of transacting.
Okay, that makes sense.
If I
Thank you.
understood the question correctly.
Yes.
Basically, I think we try to like eventually we're gonna try to make it to be very similar like Bitcoin, I would say, right? So.
Yeah. Another question from a person who is apparently too shy to ask himself: will there be layer 2 on top of Alephium?
So that's actually a good question. I think, like, as probably many of you have read the article wrote by Vitalik about the end game of blockchain, right? So for some of the parts, I agree with the article that the end game is going to be layer 1 combined with layer 2, and the layer 1 would be a sharded blockchain. So definitely we're going to, when the time comes, we're going to have layer 2s on top of Alephium. But I'm not sure if it's going to be developed by the core team. I guess because right now the performance of Alephium actually is high enough for many things. If you compare to PayPal, and actually we can we can like right now have the same throughput for the PayPal. We have enough throughput for PayPal's loads, so that can definitely save for quite a long time, I believe. And if later we figure out that to improve the performance further, we can first increase the number of groups. That's the first way, and then we can also develop the layer 2 applications on top of it. But my personal view is that the layer 2 application or layer 2 blockchains is mostly suitable for the application specific blockchains, like stuff. It's not like designed for generic blockchain, because the user experience of layer 2 blockchain is not that great. You'll need to move your funds from the layer 1 blockchain to your layer 2 blockchain, and then you do something and then you move back to the layer 1 blockchain. This is really not great. But on the other hand, if you have like one layer 2 blockchain that is used for just one thing, I guess that is much more user friendly. So I believe that in the long term, we're going to have layer 1 plus layer 2 on Alephium as well. That's not so urgent for the moment. That's it. Thank you.
If the goal was to have some, let's say, more instant transactions, what would you say? Because we have the scalability for now. We can increase the number of shards, of group and shards, but still blocks take 1 minute. How secure is it to consider a transaction final? For example, just when you see it in the mempool, can you observe the transaction data and consider that it will be finalized within some time?
So this is definitely a problem for all the proof of work blockchains, and there are some ways to work on that. The first thing is the payment channel stuff, like Lightning Network, for example. You can have very like instant finality. The assumption is a bit different. So it really depends on how much money you send, right? If you send a few coins, probably latency is not an issue for you. You can, when you see the transaction in the money pool, you probably can see it to be finalized. If you send like over 1 minute on some of the proof of staking blockchain, you like projects claims that you have the guarantee that it's finalized immediately, but I guess you the bet to watch it for several blocks to make sure that it's confirmed. So really it depends on the amount or the number of coins you send on any of these blockchains. But of course, for proof of work blockchains, we need some kind of layers or some other techniques to make it more efficient. And also it depends on the application. For example, if you want to move your coin from exchange to your personal wallet, this actually you can consider it to be finalized immediately, because anyway you trust exchange for hosting your coin. So when the exchange send money out to you, because you are still using the same assumption, you should consider it to be finalized immediately. If you send your coin to another one, this is a different case. So that with this example, I want to say that it really depends on the exact case you are doing the transaction. And there are some tools or some techniques like Lightning Network, like layer 2 to help you reduce the latency. Like payment channel is kind of like layer 2.
Yeah, yeah. So my take on what I'm taking out of this is layer 2s are silos, and if you want to interact with others, you probably want to do it on chain.
Yeah, that's true. For now, it is like this. There's some project try to bridge different layer 2s. It's not that usable for now, but maybe in the future, people can come up with some nice solutions.
Great. Do other people here maybe have any questions? Because I know in Neuchâtel they are looking to have their beer, because we have the beer to beer right after the presentation usually. So if you have any question, please jump in. The button on the left of the microphone.
If you want to continue the discussion or ask me anything on Discord, feel free at any time. Probably my written English is much more clear than my my spoken English.
Yeah, thank you very much. I think I'm still hashing a I hope we can have you in Neuchâtel physically at one point, Cheng.
Yep. I'm looking forward to see you all in Neuchâtel.
Great. So let's probably wrap up. In Neuchâtel, the presentations are restarting in January next year. In the announcement of this presentation, you have the dates and the topics of the next presentations, so don't hesitate to show up in Neuchâtel. Thanks, everyone.
Thank you very much, everyone. Cheng, thank you, Cheng. Good luck for the Elysium team.
Organizing all this. Thank you. Ciao. Bye.
Bye.